Hola y bienvenidos a un nuevo episodio de TECHarlas. Sé que hacía varios meses que no grababa esta sesión de podcast y lo hago realmente cuando conozco a gente interesante, no me he marcado ningún objetivo. Si conoces gente interesante o directamente quieres proponer temas y yo buscar a unas personas con las que poder hablarlo, déjame en los comentarios e intentaré hacer estas sesiones más a menudo. Hago esta mini intro porque para avisar que el podcast es en inglés y si tenéis un nivel mediocre como el mío, disculpad de antemano, podéis activar los subtítulos de YouTube tanto en inglés como en castellano para seguir mejor la sesión. No tenía pensado hacer ninguno en inglés, salvo que gracias a Felipe Cruz, que lo conocí en la sesión número 3, si no recuerdo mal, me dijo que era una persona muy interesante, Kyle Quest, y sin duda lo es, y su herramienta de Slimtoolkit, la verdad que es muy potente y os recomiendo a todos probarla. No me enrollo más, os dejo con la sesión del podcast, que ya es bastante larga. Hasta luego. Hello everybody and welcome to another TECHarlas podcast sessions, and this is the first one held in English and it has a simple explanation. We have a special guest, Kyle Quest or Q from United States, and he asks again to come to this channel because we tried to record this session some months ago, but for some technical users, but just forget it. We have another opportunity to talk again about containers, security, and your own tools, called Slimtoolkit and Autonomous Plane. And I'll let you introduce yourself, Kai.
Great to do it again. I actually liked that it didn't quite work first because we're doing it again, and there's new stuff to talk about, and I'm excited to talk about it. So you mentioned a few things about me already, and online I'm also the Docker Slim guy. I didn't come up with that name. It's just something that others called me because I created the Docker Slim open source project. I created it during a hackathon project. Docker had a while back. They used to do these global hackathons. It was pretty cool, so that's where I created the project to create production-ready containers, the easy way. So you don't need to be an expert on containers and don't need to be an expert on security and still get the outcomes that you'd want, because when you create a container, it's more developer friendly, but then when you need to get it to production, there are a lot of things that you need to do and know. For example, you need to know about layers, you need to know what to put first, caching and deleting stuff from containers is not straightforward. It's one of those gotchas. If you're a Docker expert and container expert, you know about those things. If you remove something, you don't actually remove it. But for the masses, that's just too much information. And that was one of the reasons why I wanted to have the tool, wanted to see if it was possible, and just wanted to have an easy way to accomplish it and not change the whole thing, the whole setup, because still it was the case back then, and it's still the case where when people talk about production-ready containers, they tell you need to change this, you need to change that, change the base image, change the tooling, and that's a lot. Asking people to change is hard when it comes to everything, pretty much everything. Food, ask people to change what they eat. That's difficult. Ask people to change what tools they use. That's difficult. So that was one of the goals. You use what you have, don't change anything, and you get the same outcomes that you'd want to get otherwise. So I created the project, and it took a while before it became popular. And it started by helping you shrink container images. And one of the benefits there was a reduced attack surface, because when you have a big container, you have more stuff in it, right? And then when you shrink it, you have less stuff in it. And because of that, naturally, your attack surface is smaller and you have fewer vulnerabilities. And that's interesting. When it comes to vulnerabilities, there are a lot of things to explore there, and we'll get to it. But that's how it started. But then a number of other capabilities were added to it later on in order to make sense of the container images, to see what's inside of them, and then to also debug them. Because when you shrink container images, you get those minimal container images, which are great, but sometimes they're not easy to use because you don't have a shell. Normally, when you have a containerized application, it's running, you can connect to it with kubectl exec or kubectl or Docker exec, and then for that you need to have a shell. But with minimal container images, a lot of times you don't have a shell, so you need to have something in order to make those containers usable, because developers otherwise won't use them. If they can't debug them, they won't use them. They don't want to use them. Security is not more important than functionality. So that's one of those basic things that security people need to be aware of. But anyways, so I created the Docker Slim project, and later on I ended up founding Slim.ai, where we tried to leverage the project, and we focused more on the visibility side of things. And then now I'm also a founder of Autonomous Plane, where we're using the project as one of the core components. And then we're building a lot more around it and making it more automated. That's the autonomous part of it. And we're focusing on the security value, where you can automatically eliminate a whole bunch of security vulnerabilities in application dependencies, and do it in a completely automated way. So in a way, it's an agent that does things for you, very dedicated. And we're kind of taking what we've learned with the open source project, and on the commercial side, all those learnings, and we're trying to automate and simplify all of the rough edges. Because when you're using the project, for example, Docker Slim, Slimtoolkit, Mintoolkit, you need to know about the flags to use. Sometimes you don't need any flags, but a lot of times you do need to add a few flags. For example, if you have an HTTP server application and you have, let's say it's made with Python or Node.js, and you have a few endpoints there, you might want to probe those endpoints, because that's one of the things that the project does. It does static analysis and dynamic analysis of your containerized application and the container. And for the dynamic analysis part, there's a default set of probes that it executes, but then you can add custom probes, and a lot of times you actually want to do that, and for that you need to know about the probes themselves, the flags, and how to add them. And one of the goals there, one of the examples there is to automate that part as well, where it's automatically discovered, and all of those flags and probes are automatically created. So that's the idea, to automate all of those activities, the inner loop of minification and security, and the outer loop, the workflow around it. So that way you don't need to do anything. So that's where I'm focusing on now. And like I mentioned, the goal is to have this autopilot or an agent that automatically fixes vulnerabilities in application dependencies, and getting rid of vulnerabilities historically was one of those benefits you could get from the Docker Slim project as a side effect of shrinking stuff.
Oh, that was a lot of nice key points in a short period. So for recap some things, as you said, building minimal image let us improve the security, reducing the surface attack. When you have less packets, you have less probabilities to have vulnerabilities. And the other part is the efficiency. Having a smaller image to transfer to the storage is better for the throughput, right? So for something, as you say, that tool, Slimtoolkit, in that case, let us or help us to build minimal image automatically, and that's a nice key point because as developer perspective, mainly probably it's not a specialist on container part. He needs to learn about multi-stage distroless, all the things are related about containers, and to finish he needs to know how to debug that image that is probably in some moments are not the most comfortable to do it in production without sale, as you say. So we can start here in the minimal or building minimal image if you want. And if you want, we can see the demonstration about the Slimtoolkit to build minimal image and start with him.
Sure, and a couple of points with minimal container images and container best practices. So with the container best practices, one of the best practice there is to, says there, you should have only the things you need in the containers that you deploy to production. But the problem there is that it sounds good in theory, but in practice, it's hard to achieve because nobody puts stuff they don't need in their containers intentionally. Nobody says, I just want to put junk in my container images because I feel like it. Nobody does that. The reason they end up with a lot of stuff in containers is because they think they need it. They think their application needs it. They don't necessarily know everything that their application needs, because an application is more than the source code that you check in to GitHub. That's just the tip of the iceberg. There's a lot more you end up deploying to production, and that code that you check in is just the tip of the iceberg, and there's a lot more that you need to know. So even if you're an application developer, you don't necessarily know exactly what your application needs at every layer, and that's the first problem why the theory and reality don't match by default. The other problem there is that it's a lot of low-level knowledge that you need to have, and then having to, you have to reverse engineer the application, what it needs at every layer, and then you need to rebuild your application, your Docker files, etc., in a way that's very advanced in terms of how you put together. So there, now you also have this requirement to know a lot about containers, a lot about the related tech, and not everybody knows that and has that kind of domain knowledge. And going the other way around, where you say, okay, I'm going to use the images that I have, but I still get the small minimal container images is more practical for people. So let's see if we can do a quick demo there.
Of course, just a short point here. As you mentioned, probably some developers don't have the knowledge, probably, and you think that that is consequence of DevOps philosophy, because in the last years we was moving all the processes about building, testing to pipelines and GitOps philosophy, and probably the developers have to achieve more requirements about building image, testing the security about containers, and probably it can concentrate more work in their hand.
So this is the whole idea of shifting left is interesting. And initially, when that term came up, it sounded exciting because it means more power to developers, which is great. But then, if we use containerized applications as an example, and DevOps in general, that's actually a problem, because one of the definitions of DevOps, there are many, but one of the favorites that I have is DevOps is you build it, you run it. Super empowering. Developers now are able to do a lot more. They don't have to rely on a third party, but that also means they need to be knowledgeable about a lot more. So now they have two jobs. First of all, they have more to do. And second, they need to be experts in infrastructure. They need to be experts in ops. And that's a part of this traditional shift left movement. Developers end up with more stuff on their plate, and they already have too much. And so it's about how much work they have and also the domain knowledge they need to have. And it's just not realistic to expect them to be experts. And that's why it's not enough to just shift more stuff left so developers have more stuff to do. You also need to enable developers to accomplish the outcomes in a way that doesn't require the level of domain knowledge that currently is required, and doesn't require the amount of manual work that you are stuck with right now. Because it's kind of one of those elephants in the room. A lot of DevOps activities are manual. Yes, the last step of the process is automated when you're deploying, but before you get to that point, you need to do a lot of things to reverse engineer the application and what it needs, to figure out the parameters, to figure out the resources it needs, to create that Docker file, to create the Kubernetes manifest, and all those other things. And those are manual activities. And then when it comes to ops, there's also more manual activities. So you can't just add more stuff to developers' plate and expect them to do that. You need to eliminate the manual activities, and you need to reduce the domain knowledge requirement in order for this to be realistic. And that's one of the goals there, and that's what you accomplish with the project. And yes, there are certain things you need to know there. It's not fully automated. That's the whole point of autonomous plane, where we want to go with it. It's an engine. It's a low-level engine, but on its own, it accomplishes a lot in terms of reducing the amount of domain knowledge about containers and reducing the amount of manual work that happens. And that's what I'd love to show. And of the classic example.
Okay. Let's pass to the demo.
Here's an application that will minify, and it's an application that I used at the cloud native regex talk when we first connected, and it's also the application I used last week at SecurityCon in Seattle. Where we created a containerized application. It's an OJS application, and then we had a story about trying to release the application to production. So it's a simple Node.js application with a couple of endpoints to provide information about the node where the application is running. It's using system information as one of the packages, and that's the package that has a vulnerability, a known vulnerability. I wanted to include that vulnerability so vulnerability scanners would pick it up to make sure that they find something. But I ended up having a lot of vulnerabilities in that image once I created it. One of the reasons is because I ended up using a slightly dated Node.js base image. If we look at the Docker file, it says that it's Node 18.1. That's definitely not the latest. So there are a few vulnerabilities there. But that's a great example. If you go to the project side, it uses Nginx as an example, but it's too simple. This is a much better example. So this is the application that we end up minifying and shrinking. And just to jump ahead, what you get with that application is a lot of vulnerabilities. And that's a screenshot from Quay. I created that application, containerized it, and I pushed it to Quay. And then Quay reported a whole bunch of vulnerabilities. So let's see what happens when we minify the application. And for that, I'll switch to the console, and I'll stop presenting, and then I'll share again. share. Okay, you should see my console.
Wait,
Great.
your terminal.
So what I'm gonna do, I'll say mint, slim, and then I'm not gonna provide any parameters to it, but I'll provide the name of the containerized application, and let's see what happens. And this is the most basic way to call a Docker Slim or Mint Toolkit or Slim Toolkit. Now with the new name Mint Toolkit, it's the CLI name is Mint. So what happens there is that it creates an instance of the containerized application, and then it interacts with that application. And if we look at the output right there, we see a probe where it runs a get root path command against the application, but then it can do a lot more if you provide additional parameters, additional probes. And then if we look at the results, the size of the original image was 1 megabyte, and now it's 93 megabytes. And the image is now 10 times smaller, slightly more than that. And if we look at what happens with the image, and I'll use a local scanner, I'll scan it with Gripe latest, but it works the same with Docker Scout and all of that. You should get fewer vulnerabilities there.
Yes, more or less the same results in many tools. So to make time, to resume, the tool launch and execution of the container analyze dynamically in runtime what ports are opening, what syscalls are calling in Linux kernel, right? What kind of files it depends of the execution, and cleaning all that not necessary in the image, right?
Exactly. So what happens? The tool performs static and dynamic analysis. It statically analyzes the container, it statically analyzes the application, and then it dynamically analyzes the application as well when it creates an ephemeral instance of that containerized application, and it has a sensor that gets inserted into this ephemeral instance. It's an in-container sensor that gets called when that ephemeral container instance is started. So that way the sensor starts, and then the sensor starts the application, and then the sensor observes the application using different monitors, different types of monitors. For example, one of the monitors is based on the FA notify capability in the Linux kernel, and this is the capability that virus scanners and antivirus scanners use in order to find viruses. And it tells you a lot about the application at runtime. And then it also uses ptrace to intercept the syscalls and to see what the application is doing and what it's trying to access and other operations. And then it combines that information with the statically collected information about the application, and then it creates a manifest that represents the application blueprint. And then based on that blueprint, it rebuilds the containerized application, and it creates a new image. So when we used Gripe to scan the minified image, we ended up with a few vulnerabilities. First, initially, I showed the Quay virus scan result, where it was thousands of matches, and now it's fewer, and it's easier to see what's there. And if we look at it, there are a couple of system information package related findings, which is exactly why I ended up minifying the container image in the presentation, in the original presentation I did, because the scanner showed way too much information, and I couldn't find the vulnerability I needed to show, and I needed to exploit, because that's what I did. I ended up exploiting the vulnerability in system information to prove a point. And here, what happened there, we rebuilt the container image. It's much smaller, like I said, 10 times smaller. It has fewer stuff in it. And as a side effect, we reduced the attack surface and we removed a whole bunch of vulnerabilities. And now it's much easier to deal with that. It's much easier to deal with these findings. Looking at the descriptions, imagine looking at the descriptions for 1,000 vulnerabilities. That's 1,000 pages. Reading through it, and if you have to triage, fully understand the vulnerabilities, it's more than a single page per vulnerability. So that's a lot of time. It adds up when you have that kind of scale. And even if you have hundreds, it's still a lot of time. It's much easier to deal with a couple of dozen vulnerabilities. So that's one of the side effects that you get, and you have a small container image, but one of the not gotchas, but one of the properties of those minimal container images is that you don't always have shells. So now it's not debuggable in a standard way, and that's the question that comes up with developers. So you created this minimal container image, but how am I supposed to debug it? What do I do with it? Because I'm pretty confident in my application, but it may crash. I may need to debug it, and I need to be able to debug it. And usually I have a whole bunch of tools I can use in the container image to debug it. Now you remove all of this stuff, I don't have those tools. I don't want to use it because now I can debug it. So that's why after the initial minification capability, I ended up adding the debugging capability, so you can bring the tools that you need when you need them at runtime to debug your application. And we can take a look at that as well, or we can discuss.
No, it's interesting for me, the debug part. Just a point, I work on the security perspective, and it's our daily problem here about manage the bunch of hundreds vulnerabilities that could generate that kind of tools reporting about containers. And when we talk with a developer, it's okay, it's better to understand the vulnerabilities, start again the building of the image with a slim base image, working with minimal versions of the image. But that kind of tool could solve a lot of problems, as you mentioned, automatically without container knowledge. And for me, that's a win-to-win to both of them, as security perspective and a developer experience. It's totally nice.
Yeah, so we can pick a minimal container image and we can try to debug it. Okay. One of the most common minimal container images that don't have a shell is the Nginx container image from ChainGuard. They're known for having those kind of minimal container images for applications like Nginx and base images to build your own application. And the Nginx image is a good example. By default, there's no shell, so you can't debug. For example, I have a few manifests here, and we can take a look at what's in them. So here's a simple Kubernetes manifest. It has a single pod declared in the manifest with the ChainGuard Nginx image, and it's the latest image, and that image is not a debug image, so it doesn't have a shell. And if you try to use kubectl debug, kubectl exec, that is, you won't be able to connect to it, but you can use kubectl debug. That's a great tool, but it has rough edges and it's a low-level construct. For example, let's actually try to do that. Kubectl debug. So let's see.
So you're going to launch a pod with a shell in a Kubernetes cluster and attach later again with a debug tag with a shell and all the tools necessary to debug a container in production.
Yeah, exactly. So let's start the pod with kubectl get pods. All right, so the pod is running, and we can let's try to kube control kubectl exec. Let's see, exec. So let's see, exec. It's example pod container example container dash bin shell. I wasn't able to connect to it and use exec because there's no shell.
Yeah.
Luckily, there's kubectl debug, right? And there you, so it's creating an image. It's creating an ephemeral container instance. So with Kubernetes, that's what they use. They create ephemeral container images, container instances behind the scene, and they attach that ephemeral container to the target container with namespaces. And if we look at what we have,
starting the process, the PID process, right, and the storage of the container that you are trying to debug.
Yeah.
Okay.
Yes. Hooks. All right. All right. So, but what? Which Nginx? But if I try to look for Nginx, it's not there, and that's because.
Okay, so you are not sharing the users and the processes of the container.
Yeah, it's because I'm connected to the file system of the debugging container, not the target container. So this is one of those low-level. This is an example of those low-level constructs you have to deal with. You need to know about the file systems and how to navigate to the target, and the target is available through the proc file system. And if we look at that, we'll see this is the this is the file system you want to see. And let's see, etc. And right there, all right, network password host. Okay, so right there we have the file system of the target container, but you don't access it directly, and you don't have access to other things in the target container directly. And that's why that's what you can accomplish with the debug command in Docker Slim or Slimtoolkit. It gives you a high-level interface to interact with the container. So I'm going to exit from that, and I'll use Mint, and I'll select the debug command. And then I'm going to select the runtime. In this case, it's Kubernetes, and then I would select the namespace, the pod, and the target, for example, right
it
there.
It could work remotely with the cluster, right? Not just in local. Okay.
Yeah, and the nice thing about it is that here you have autocomplete, so I don't need to know the names of the parameters for the namespace, for example. But it has nice defaults. If you have a simple setup, I don't need to specify the namespace. You can go to pod, and right there it shows me, hey, I have this pod running, and I can select it. And that's an example of a much nicer user experience, because you don't need to remember, cut and paste the names, because you don't always have the nice names. And then there, I can pick the container that I want to debug. And again, I have an autocomplete where I can select the name. Then behind the scene, Docker Slim discovers what's in the cluster, discovers the namespaces, discovers the pods, discovers the containers, and it uses that information to autocomplete. And then I can also specify a debug image debug image. And there as well, I also have a number of autocomplete options, including BusyBox and a number of other container images that you can use for debugging. And different debugging container images are designed for different types of debugging for different applications.
Yes, you could have a custom image with your preferred tools to debug.
Exactly, but here there's a nice list of pre-configured debug images. And right there, when I connect to it, here let's see, PS. Here I actually see the Nginx application running, and if we look at the file system, etc. Now here I have Nginx, and if I say which Nginx, it finds Nginx for me. So I'm actually connected to the target container file system. So now it feels like I have a fat image or an image with all of my tools, and it's running. I have my application, I have my tools, and I can do what I need to do. If we look at the command output for PS above there, you see a few records that look kind of interesting and strange, and that's a little bit of magic behind the scene used to accomplish that user experience, because it ends up using change root command to switch to the file system of the target image, and then it connects the path from your debug image to your target environment, so you can access the tools that you have in one place. So if we do LSA, you see there's a number of hidden directories, and that's how it connects the bin, user bin, and user as bin directories into this environment, change root environment, and that's how I can invoke commands. So that alone makes it a lot easier to use. You don't need to know about the proc file system, and there are other problems if you have, let's see, exit. So if we look at some of the other manifests, non-root, YAML. So if you use more restricted configurations for your Kubernetes cluster, but they run as non-root configured, then it gets even trickier, because the Nginx application is running as non-root, and if you try to do kube control debug to that image, to that container, but BusyBox or other debug image, you're gonna get an error saying that can't connect and permission denied, because there is a disconnect between the user IDs from the debugging image and the user IDs in the target image, and that breaks the debugging session. And it's another example of having to know the low-level details, and as a developer, you normally don't know about all of those things, and here you don't actually have this problem. For that particular mode, I can restart the example and use this manifest, but I'll just talk about it. What Docker Slim does, it checks to see if the user IDs mismatch, and then it selects automatically. It tries to automatically select the right user ID to run for the debugging session, so then you don't get those access denied problems.
So by default, you take the UID of the running processes, but you can change to use a root user to be more comfortable debugging the images without the limitation of the security policies.
Yeah, Exactly. So that's
really
the
cool.
whole idea of a nicer user experience, because something that's closer to what developers are used to, and that's one of the goals. And the nice thing about Docker Slim is that it supports multiple runtimes. So here we looked at Kubernetes, but kubectl, get pods. Let's see, kubectl, delete file. I can do podman, run. I'll use a slightly different image, just so it's easier, because I'm not sure if podman is configured with a minimal container image. So I'm gonna use a regular Nginx image.
Okay.
Nginx, and if I run it, okay, the image is started, and if I do clear, oh, oops, it's sharing.
Just the tab.
Okay,
Launching the mouse if you need.
okay, let me present something else. Okay. That's a nice
No problem. Yeah. There are a lot of technical issues, but
okay, how about this? Now you can see it. So if I do podman, podman, okay. And then what's the command? PS.
okay.
That's silly. So I have the image. I have the container running with the Nginx image, and I can use mint, debug, and then I select the other runtime, and I use podman, and then right there, if we look at the
automatically fetching all the running containers, that's cool.
Yeah, exactly. So regardless
the user
of
experience of the CLI is totally nice. And for as we are talking, more of the developers are not comfortable with CLIs, because there are no sysadmins, and most of them hate the CLI. But with that kind of tools, with that auto-completing, is more easy to use. Yes.
Yeah, and right there, I'm also connected to the target container, with the target container file system. Like right there, I did an ls, and it showed me Docker entry point, .sh, and that's the standard kind of wrapper script that you have in the default Nginx image. So as a developer, I'm more comfortable interacting with the container because I see the file system I need to see. I can access the tools I need to access in the target container and from the debug image, and then I just take it from there. So and it's nice to be able to do it with all runtimes.
Yeah, totally agree. So it's a nice tool. It's a nice tool to have in the same commands the tools necessary to create a slim image and debug a small image. That, as we talked in the first introduction of the session, you need to create a slim image. It's okay, but there are a lot of consequences of generating secure image, and one of the most important is that. And with a tool like that to debug that kind of image, we are totally covered to have skills to create a slim image.
Yeah, exactly. But when I ran Gripe, we got pretty good results. Smaller number of vulnerabilities, and a much smaller attack surface. But there were still some vulnerabilities. And in the talk last week, that's one of the things that we explored. What can be done to hide the vulnerabilities and to do it in an automated way. And that's something that you can do for Node.js applications with the latest version of Docker Slim, where you can hide the results completely. If I let's see, if I go back here and then I'll stop that and then okay, so manifest debug. I'm gonna get that image. Okay, let's.
Okay. I was saying that you are not
Okay.
Okay, now yes.
So there's this flag called obfuscate metadata, and if I use this flag, it actually hides vulnerabilities. It breaks vulnerability scanners, so they don't see the vulnerabilities that are inside, and it does a number of things, and then tag obfuscated latest. All right, if I run this with the obfuscate metadata flag, okay, let's see. I guess I didn't type it right. So mint slim. Okay. I'll put where is it? Slim help. Okay, now we get more data. Obfuscate.
You left the F, I think.
All right, so I'm just trying to get the flag right. Tag.
Okay. See.
All right.
Okay.
Okay, now it's doing its job, and it's going to go through the same process. It'll statically analyze the container and the application, dynamically analyze it, but then it'll do a few other things on top of that. It will hide the Node.js runtime, so the vulnerability scanners can't find it, and then it hides the packages inside. So if we
it removes the package JSON files and other kinds of package declarations on an application.
It doesn't remove the package metadata completely. It mutates it. It changes the metadata that the vulnerability scanners use in order to look up the vulnerabilities. So if we run gripe again against this obfuscated image, it'll say that we have 0 vulnerabilities.
It's a powerful tool, but it's dangerous too because probably a bad usage of these kinds of tools could allow some developers teams pass the security controls, but don't know nothing more about security.
Yeah, exactly. It's a nice trick, and it just shows that the vulnerability scanners are very basic and brittle. It's easy to break them. For example, a lot of them break when the containers are minified, because the operating system and distribution information is removed, and that confuses a lot of scanners. Some scanners are okay without that, but a lot of them get stuck just there, and then the OS package metadata gets removed because it's not really needed. That also breaks other scanners, and then the application package metadata gets mutated, but that's done by this special flag. And if we use Sift, it'll it'll report the package information, but the difference there, and I don't know if it's obvious or not, the versions are different. So you see it's 11, 11, 10, 13, and in the original packages, I don't have that part shared, the version of accepts, for example, is 1.3.8, and now it's 11.3.8. So by changing the version number to a bigger number, it breaks the vulnerability lookup. For example, system information, it's 14.34.10, but in the original, if you look at Docker file, at the Docker file from the application, not the Docker file, but package.json, the actual version is 4.34.10. So right there, because of that, no vulnerability is detected, even though it's the same package.
So just to clarify, Shift is the SBON tool, generator tool, and Gripe is the scan or vulnerability analyzer, and both of them work together to analyze the vulnerabilities on package, for clarify this point. But it's really interesting probably the limitation of that kind of tool that analyze statically the image or the package of the image to detect vulnerabilities, right?
Yeah, and there is more. So here we're still getting results from Sift, one of the most popular SBOM tools, but there is a way to hide packages from Sift completely. So there's this other flag called obfuscate app package names. And there are a few parameters you can specify there. One of them is empty. When I specify that, and let's try to do that. When I specify that flag, it will it'll remove the package names from the package manifests, Node.js application package manifests. And when that happens, it's going to go through this process again to analyze the application. But when it happens, Sift doesn't see any packages, and it's going to report 0 packages at all. So it's not going to find any packages at all. So let's run Sift again, obfuscated. And right there, we see 0 packages. And if we run Gripe,
like magic.
yeah, exactly, like magic. And Gripe will still report no vulnerabilities as well, because it can't find the packages. It doesn't see the OS metadata, etc., etc. So yeah, it's magic, but again, it shows that there are certain things that that break vulnerability scanners and SBOM generators, and by doing that, you can impact the outcome of those tools and get the results you want. So that's a way not to fix any vulnerability, but obviously you do want to fix vulnerabilities, but you do want to have a way to know which vulnerability you should care about. And when you minify your container image, that's an easy way to know. You scan the image before and then after, and you look at the vulnerabilities reported after, and you focus on those, and focus on those and ignore the scores, CVSS scores on those vulnerabilities, because those don't matter. If you look at the values there, they're generic in general. So I don't know if a lot of people know about it, but if you look at the National Vulnerability Database, the kind of the go-to source for vulnerabilities, and you look at a score and severity, that score and that severity is generic, A, and 2, it's a base score, meaning that it's just the starting point, but it's used as if it's the actual score. So that's one of the problems. it is just a starting point for calculating the real score, but it's also generic, and it's also the worst case scenario, and that's just not realistic. So my recommendation would be to ignore the CVSS score values and focus on the vulnerabilities that are relevant to your application, and then go from there.
It was a new score, I don't remember the name, ASBUS, or I'm going to search now, but it is with the criticality of the vulnerability and some context, it can determine you the exploitability of that vulnerability in your context. But that probably you are not exposing the application over internet, over a network, but sometimes it's hard to determine, and from CISO perspective that I have, sometimes you are blocking a lot of projects, a lot of dependencies that have the projects. It's hard to analyze one by one in their context, and it's a really hard problem in that
Exactly.
place.
Yeah, you're supposed to, with the CVSS score, they give you a base score, and then there's a formula to create the real score, and there, for that formula, you're supposed to use the environmental and temporal information in order to determine your score. The temporal information, is an example of that is the availability of exploits. Let's say there was no exploit when it was first discovered, but now there's an exploit. Now it's different. Now it's more critical to fix it. But then the other example of information you need to use is the environmental information. But you don't always have that information, because sometimes you don't have access to the environment where it's deployed, and sometimes it's not deployed at all. That's one of those gotchas that you deal with, because when you're deploying an application, a new version of the application, by definition, you don't have that application running in production. So you can't just connect to the production environment to know that, I have this environmental information I can use. It's this catch-22 kind of thing. And the nice thing about what you get with Docker Slim, Min-Toolkit, is that it gives you the runtime information before you deploy. The dynamic information that gets collected using ephemeral instances gives you that information that makes it super helpful. And I'm sharing another screen, an example of how the system is broken, the CVSS system is broken. So this is a vulnerability in a node package to check IP addresses, and they assign the base score to be 9.8, which is critical. And in reality, it's not it's not really critical for a number of reasons. It was the package here is to do a check on an IP address. What's missing here is the fact that this package is analyzed from the security perspective as if it was a web application, because you deal with server-side request forgery in web applications. You don't deal with that in other contexts. So here, that's an example of a bogus CVE and a bogus score, because it's just completely unfair to score the package as if it was an application. So the system is broken in many different ways, and that's one of the examples, and that's one of the reasons why you'd want to ignore the score. Luckily, GitHub advisories, they scored the vulnerability as low, but the main point is that you can't trust the score you get from NVD, because it's a base score, it lacks the context, and because a lot of times it's not a good score anyways, and it's the worst imaginable outcome that's represented by that score. And it's just not realistic. It doesn't help. It gives you a lot inflated scores. It gives you a lot more work, and then in that noise you lose the vulnerabilities that are really important and you want to fix. So the system is broken and it needs to be fixed. And
that's totally true. I was remembering the Log4j vulnerability that was 99.82 and was a real critical vulnerability that affects all the systems exposed, and that, as you say, you are comparing two kinds of vulnerabilities with the same score theoretically, and impact totally different in the real world. But yes, this is probably in the future we can create or we can establish a new standard, for example, with the content or the information context, to try to improve this, because there are a really hard problem now in large companies to determine it, because in my experience sometimes in CISO teams, and I talk for myself too, there are a lot of risk management tools, a lot of people dedicated to analyze that kind of vulnerabilities, that see, okay, it's a critical vulnerability, the NIST is or golden source of knowledge is critical, I can let you deploy that application with a vulnerability, and sometimes it's frustrating. Yeah.
So one way to approach this problem is to treat applications and libraries differently, because libraries are always used in a certain application context. You might not want to have a score at all, but you might want to have a set of properties and a set of behaviors that then can be used to calculate the severity and the impact for the application. That way you don't have a score for a library, but you have useful context about the vulnerability that gets pulled in when the application score is calculated. So that way there's no opportunity for misuse. And then for applications, you use the application context as the foundation, and then you build everything from there. So that way, and then you pull in the context from the library record, and then you end up producing a value. You know, the gotcha there, not the gotcha, it's just a different model, and you no longer have scores everywhere. But I think it's a disservice to have those scores, because again, it's a base score, and it's misused right out of the gate, and it just doesn't help. It does more harm than good. So I would suggest removing scores from libraries and then generating scores for applications, but build those scores for those specific applications, and not have generic scores. I think it'll be better that way. And yeah, we may not have a score everywhere, but it's actually better not to have a score than to have a bad score, because it results in wasted efforts.
Totally agree. We need to improve a lot in that part. So I don't know if you have time to see more and check the last part. I think that is the autonomous plane, or the part of the remediation, right?
Yes. So with the Docker Slim tool and the demos I showed, in the intro, I talked about, and then later on when we looked through the demos, I talked about the different parameters and all that extra information that you might need to know. But autonomous plane, the idea is to automate everything that's related to Docker Slim. So you have the core engine there, and then the manual activities to run the application, to probe it, and all of that, to adjust the parameters. Those kind of activities can be automated, and that's the idea. Automate the adjacent activities, and focus on the most kind of valuable aspect of what you can accomplish. So with autonomous plane, what we want to do ultimately, we want to enable a future where developers can focus on writing awesome applications. So that's where they would focus. They wouldn't think about ops, they wouldn't think about infrastructure, they wouldn't think about security. They would focus only on writing the application. And then once the application is written, you have a set of autonomous agents that are dedicated to different types of maintenance and management activities. And one of those activities is security maintenance, specifically fixing vulnerabilities in application dependencies. That's one of the categories. And that's where we starting because it's the closest thing to what we can deliver because of the open source project. It is an engine, but there are a number of activities, manual activities that still have to happen. So we want to eliminate that extra manual work that's still.
To resume, is the packetized version of all that tool that you are seeing with a management service of to facilitate or to make easier all the experience.
Exactly, and it's not quite an autonomous plane demo, but it is an AI assistant for Docker Slim demo that I can show, and I can show what I mean by automating different activities and simplifying the user experience. So let's see. So I'll run. So the assistant is a Node.js application. So the first thing it does, it asks for the container image for the application. So it knows the context. And I paste the application container image name there. Then it asks for the question I want to ask. And right there, I'm gonna ask, how can I hide vulnerabilities? So I knew when I did the initial demo to obfuscate the metadata, I knew about the flag. But what if you don't know about the flag? You're just using the tool for the first time, or you're not an expert. You probably wouldn't know about the flag. And the idea with the assistant there is to use the domain knowledge about the tool and about the container to automate the different steps related to that. For example, here, let's look at the output. So it took a while to look up the answer because it's not streaming the output to save on the tokens. And the first section here, if we look at it, it gives me a high-level overview of the application. It tells me the runtime. It's a Node 18.1 runtime. It gives me a list of dependencies, direct dependencies. It says that I have Express and system information as dependencies. Then it tells me, hey, you have a server application listening on port 1300, and then it gives me a summary about the endpoints that are exposed. So now, let's say I'm a DevOps engineer, I didn't write the application. Now I have insights about the application and what it has in it. And then it gives more information about the exposed APIs. So now again, if I'm a DevOps engineer or a security engineer, I know more about the application and what it's doing. And the next section, in this section, it actually gives me a CLI command for Docker Slim, for Mint Slim, to do everything that I need, and it gives an explanation of the flags. So one of the flags right there, it gives me in the snippet is obfuscate metadata. Great. I got the flag that I needed, and then it also gives me several HTTP probe flags to probe the endpoints in the application. So it just figured out that I needed custom HTTP probes, and it provided them to me. So that's an example of automation that you get around using Docker Slim as an engine, because you need to figure out the flags, and here it did it for us. It figured out the flags, and then it gives a kind of a high-level explanation. For example, for the obfuscate metadata, it tells me what it is. The flag is used to obfuscate system and application metadata to hide vulnerabilities and prevent vulnerability scanners from detecting them. And then it describes the custom HTTP probes and what they do and why they're there. So that's an example of automating things that you do when you're using Docker Slim, and then there's a lot more that can be done there. So that's a stepping stone towards full automation we want to accomplish with autonomous plane, where you literally just say, "This is my application," and then you get the reassembled and improved application after that, where you don't have to do anything. It'll figure out the kind of interactions it needs to do. It figures out how to adjust parameters. It figures out if the application is still okay or it's broken. It automatically reruns the application behind the scene and all of that. So automating everything imaginable around that.
Oh, it's really cool to see the capability to list all the API endpoints. Probably some teams don't know all the routes that they have. Mostly it can have I forget the API definitions tool. Yes, Open API test. I think the most famous is it's a web app with all declaration. I forget the name too. A swagger. When you have the swagger of the application, and it's cool to check that the application could detect dynamically all the endpoints. And give you the command prepare it, because if you have 30 endpoints, so you're going to have a command large than a stadium. So it's nice to have that kind of tool. Yeah.
Behind the scene, what happens? The application is analyzed, and the API call and endpoint information is extracted, and then an open API spec gets created with the metadata that's extracted, and then based on that open API spec, it ends up generating these custom probes in order to probe those API endpoints.
And the endpoints are extracted from the source code directly, and it works for all kinds of languages.
Yeah. It looks at the source code. So let's say we have a Node.js application or a Python application. The source code is shipped in the container. So there is just basic source code analysis that extracts that information, and it creates an open API spec based on that. For other languages like Java, it's a little more involved, but analyzing the application, because you need to analyze the bytecode and all of that, but it's still doable. For compiled languages, it's a little it's even more involved, but it's also doable. It's if you look at in the malware space and malware reverse engineering work that people do.
You could compile.
You decompile
or C++ or all kinds of languages. You can decompile it with some limitations, but you can see.
So you can extract the metadata, the endpoint metadata, even from compiled language applications. It's just a little more work. So it's all doable, but again, because it's extra, it's a part of this premium SaaS capability. But you can still use the core engine Docker Slim on its own. You know about the application, you can specify those custom parameters on your own, or you have something that automatically figures those things out and then it does it for you. So it's still 100% usable, and you can get the value out of it. It's just if you want to have this fully automated experience, you can use autonomous plane. If you want to do it yourself, that's fine, and that's what a lot of users do. A lot of open source project users do. Big and small organizations, engineering organizations, figured out how to do it on their own without even asking for help. it's not everybody, but there are many users like that who are happy users. They build the whole setup on their own, where they use Docker Slim as their own engine. They build the plumbing around it. But many people struggle because they don't necessarily know enough about the application. Still, they need to know less, but they need to know something. For example, one of the most basic thing you need to know is how to run the application. That's what Docker Slim needs. You need to provide the parameters, runtime parameters. And if you don't know those parameters, let's say if you're DevOps engineer, you're just building the application, you may not know about it. Then it's a problem. And that's one of the things that's possible with autonomous plane. There's an agent responsible for figuring out how to run a containerized application for you.
Yes, that's the key point, because as you say, probably a developer or a DevOps or a security engineer don't know nothing about the application, as is the most common case in medium and large size business. So it's really cool. Another question is more personal, because I'm always interested on how the business can maintain an open source version of the products and an enterprise solution. That I see that autonomous plane, I suppose that is a commercial version of all the solution. As you know, all need to gain money about their work. It's totally unstable. But for me, it's really impressive how in this case, and I don't know if you are a single person maintaining that product, but is in some moments it's a big effort that you do for the community. And I don't know if you receive the support in a community project, or the no support in a community project to be on the first line working hard. There are some moments that the community projects are not valorated and not receive nothing for their work. How do you see that state?
Yeah, that's a complicated project, because not every project is like Kubernetes. Kubernetes and Linux kernel are the biggest projects, open source projects out there, with a huge community, both of them. But that's not a norm, that's an exception. Most open source projects are relatively small when it comes to the contributors, active contributors, and they don't get enough attention. Obviously, they don't get enough funding. So it is kind of nights and weekends kind of effort. And a lot of the recent supply chain security stories that you hear these days are related to that, where somebody's maintaining a library, a package that gets used by many applications, but they do it on their own, and they don't necessarily have the capacity to do everything, and it's unrealistic to expect those maintainers to be measured as if they are a commercial vendor. And there's a disconnect between the expectations and the reality, and it is an unsolved problem, and I don't have an answer either. For example, some people suggest that you should pay maintainers, but others say that's not going to do much. And in some ways, I agree and disagree with it, because yes, if you pay a little bit, then yeah, that's not going to be enough. That's not enough money to work on the project full time. You got to be able to work on it full time. You got to be able to support your family, and you got to be able to support yourself. If you don't get paid enough for that open source project to do that, then there'll be a disconnect there. So there needs to be enough money in order to for the maintainers to completely focus on the project, on the packages that they create. In terms of the business, when it comes to building open source companies and what goes where, there are several models. One, where everything is open sourced. That's if we look at big names and examples, big name examples, that's Confluent with Kafka and the Kafka platform they have, and Elasticsearch and their platform. They ended up open sourcing their whole platform with Apache 2 license, and for me personally, it didn't make sense for them to have everything open sourced, because then it's hard to differentiate what is the value on the open source side, what do you get with the open source and the commercial side. And it was easy for competitors just to take everything and offer that as a service. And then I was a little surprised that those vendors were surprised that that happened, that somebody
Yeah.
took the whole product and offered that as a service. The model, the other model that exists is this open core model, where you have a component that's a core, and then you have premium value built around it. Then it's a little easier to see the difference, where the open core is just a subset of what you offer. So it's not 100% the same thing. So it's much easier to see. And then in terms of value, what I just described about the ability to figure out how to run containerized applications. That's a clear example of what you get as premium value in a commercial product versus the core component where you don't get it. You can still accomplish what you need with the open source component, that's the core in the product, but it's more things for you to do, versus here it's figured out for you, and now you have unique value that you can see that you get and with the premium version, and it's much easier to make a decision, because when you look at something that's 100% open source and commercial version, you're confused. So why should I pay for this hosted version? It takes a little effort to self-host, for example, or get it from somebody else. It's hard to sell. So an open core model where you have these examples where this is what you get with the open core, and this is what you get on the premium side, definitely helps them.
Yes, totally agree. And probably the core model is okay. I let you all the capabilities that you can host on your infrastructure, and when you need the most of the capabilities or the most of the features that a large company needs, as SSO authentication, high availability, a SaaS version of the product, it's okay. You are offering a service behind there, or the Elasticsearch model. The Elasticsearch model is okay. I let you the bit capabilities with authentication with a lot of users, validation, etc. So it's totally comprehensible. And there are a lot of large foundations now. We have the Apache Foundation, we have the Cloud Native Foundation that could maintain a large group of projects as Kubernetes and other kind of solutions. But how do you see the status of source code in general, looking out of that kinds of foundations? Because okay, the Apache Foundation is stronger, but small projects as you or major projects. Well, sorry, I see that your project is in the Cloud Native Foundation now, right? Is correct?
Yes. So the project became a Sandbox project a while back, and there are benefits that the project gets with it in terms of the community engagement. For example, there's a number of sessions at KubeCon EU in Paris. There were several things that I got with the project. An opportunity to do a lightning talk about the project. So that was one of the benefits that I got. It's an optional opportunity. So that then there was a Contrib Fest session opportunity. That's a new thing that they started doing. They're trying to iterate in terms of what they provide at KubeCon, and at KubeCon EU, that was an option. And at KubeCon North America, that they're also doing that as well, where they let you submit a proposal for a Contribute Fest session. So that way you can get people in the room working on the project, contributing to the project. That's the whole Contribute Fest side of it, and that's super useful. So it's great, but it's not enough though. So it's
Yes, it gives you a lot of visibility, but it cannot pay you as fully work in your open source project. It's totally.
But it's super helpful. And another benefit there is an opportunity to have a pavilion presence. So at KubeCons, they have a pavilion, open source project or CNCF project pavilion, where you have different stands for different open source projects that are in the CNCF Foundation. And that's great, but again, it's an opportunity to talk to the users, existing users and potential users, but it's not enough. Like you said, you can't live on it, but it's still super useful, super helpful, and it's an opportunity to engage with the community. So I wish there was a way to be a full-time maintainer with CNCF, with the Apache Foundation, and all.
Okay, so I think that we are near the 2-hour session, so I think that is totally enough for now, but probably if there are a lot of interest in some parts, we could make some mini sessions dedicated to another kind of session. Let us in the comment if you are interested in some kind of topic more that we can talk with Kyle. That is a really expert. He says that he's only an enthusiastic, but in consideration about my perspective at least, I can consider you an expert in containers or container killer that says now. And I don't know, Kyle, if you want to say something more to finish the podcast and yeah.
So a little CTA, a call to action, is to take a look at the project and reach out, and I'll be happy to do intro sessions in terms of explaining how it's structured and what can be done, how you can help, because there's never enough help. And a couple of one of the interesting areas where there's a need for help is the UI interface, the terminal UI interface. So we looked at the interactive prompt interface with the debug command. But one of the new things that I'm trying to add to it is a terminal UI interface, where you have a UI but in a terminal, and it's much easier to use, and that's the whole point, making the tool much easier to use. So this terminal UI interface for the X-ray command, for the debug command, for the Slim command is something that would be great to do. And if anybody is interested in doing that, please reach out. Hopefully we'll have a contrib session at KubeCon, but there'll be more to do online, and that's the goal. Get your interests, find people who are interested, and then work on those things online.
Of course, I will write all the links in the description to follow Kyle Quest. I think that you are more active on X, is right? And all the links of the Slimtoolkit in GitHub, but you can install it easily in Brew and other kind of package manager, and try it by yourself. That is totally impressive tool. And you can repeat all the commands that you see in this video and test it for yourself. That the advantage of source code, open source code projects. And I would like to give you an special thanks, Kyle, again, to come here and be patient with me with my English level, and with we had to repeat the session by the first technical users. And thank you again.
Awesome. It was great to talk about the project and what you can do with it. There's a lot more you can do with it. We didn't look at the X-ray command, and there's a lot in it. So maybe we'll do a follow-up session, but I'm happy to answer any questions online. Please reach out if you're trying to use the tool or if you want to contribute.
Thank you again. So Thank you all for follow the session. Let us in comments all your questions, and you can reach with Kyle when it needs. He's a really open person to talk about all the things, I know, I suppose. And thank you again. See you in the next.
Thanks a lot.